In this video, we're going to walk through a couple application problems of logarithms. So in our first example, you have deposited $500 in an account that pays 6.75% interest compounded continuously. How long will it take your money to double? Well, because it's compounded continuously, we're going to be using the equation A equals P times E raised to the RT, where A is our amount, our P is our principal, R is our rate, and T is our time. So we need to find those values. So we don't know what our value is at the end, our A, but we do know that our principal amount, well, we do know our A because we want to double it, right? It tells us that we're doubling. And because we started with $500, then we want to end with 1,000. We have a rate of 6.75%, but as a decimal, that's written as 0.0675. And the question is, how long will it take? And so our T value is what we are looking for here. So if we take our pieces and we plug them into the equation, that gives us 1,000 equals 500 E raised to the 0.0675 T. So to solve for T, we'll first divide both sides by 500, giving us 2 equals 0.0675 times T. And now we need to find a way to get our T out of our exponent. So because it's written as an exponential, we'll take the log of both sides. Because we have a base of E, we're going to take the natural log of both sides. So the natural log of 2 times the natural log of E raised to the 0.0675 T. Our natural log and our E will cancel out, giving us the natural log of 2 equals 0.0675 times T. To finish solving that, we'll divide both sides by 0.0675, which will allow us to get the T by itself. So we'll have T equals the natural log divided by 0.0675, which approximates to about 10.27. So what does that mean? Well, that means that it will take approximately 10.27 years to double your money. Let's take a look at another equation, or not an equation, but another example that will use Newton's law of cooling. So in this example, you're cooking a licha, an Ethiopian stew. When you take it off the stove, its temperature is 212 degrees Fahrenheit, and the room temperature is 70 degrees Fahrenheit. And the cooling rate of the stew is R equals 0.046. How long will it take to cool the stew to a serving temperature of 100 degrees Fahrenheit? So the hint here is that you're going to need Newton's law of cooling. So what is Newton's law of cooling? Newton's law of cooling is T equals P naught minus TR sub R times E raised to the RT plus T sub R. That's great. Well, what do all those pieces mean? Well, our T is our desired temperature. Our T naught is our initial temperature. Our TR is the surrounding temperature. Our little t is time. And our R is the cooling rate. And we have many of these pieces in the equation, or rather in the example given. So let's put those into our equation. So we know that we want a serving temperature of 100, and that the initial temperature of the stew is 212 degrees, and the room temperature is 70, and we have a cooling rate of 0.046. So we plug those into our equation to get 100 equals 212 minus 70 times E raised to the negative 0.046 T plus 70. So from here, we're going to get 100 equals 142 times E raised to the 0.046 T plus 70. So we're going to subtract 70 from both sides, which will give us 30 equals 142 times E raised to the 0.046 T Then we're going to divide both sides by 142. So we're trying to isolate that e so that we can solve for the t. So that's going to give us a 0.2113 equals e raised to the 0.046t. So to get the t out of our exponent, we're going to need to write this in logarithmic form because that's the inverse of an exponential form. So the base of e as a logarithm is our natural log. So if we take the natural log of both sides, that gives us the natural log of 0.2113 equals the natural log of e raised to the 0.046t. And that allows our natural log and our e to cancel out, which gives us the natural log of 0.2113 equals negative 0.046t. From here, we're trying to get the t by itself. So we want to divide both sides by negative 0.046, which will get our t by itself and give us that t equals the natural log of 0.2113 divided by negative 0.046. When we plug that into the calculator, we're going to get an approximately 33.79. So what does that mean in regards to our problem? Well, what that means is that it's going to take about 34 minutes for the stool to cool to a serving temperature of 100 degrees Fahrenheit. So from the following two examples, we've seen that logarithms can be used in investing as well as in cooking.